A compound containing carbon, hydrogen, nitrogen, and oxygen. This is kind of how the empirical formula is going to look like. Just need to find the x's for every element. So for a combustion analysis of this many grams of compound, there's gonna be carbon dioxide produced, and this is how much carbon dioxide is gonna be produced, plus some water, and this is how much water is gonna be produced. And it says that in another experiment, 0.6355 grams of the compound was found to contain 0.1834 grams of nitrogen. The molar mass was found to be 200 grams. Find the molecular formula for the compound. So with this information, I can find how the percentage of nitrogen in the compound. So I just went ahead and did that. I put the grams of nitrogen and the grams of the compound in that experiment. So I found out the nitrogen is 28.86% of the compound. Then I wanted to find the percentage of carbon, and to do that, first I found the grams of carbon, which I did this. This one I got it from here. Then I found the moles of carbon dioxide. Then I did the mole ratio from carbon to carbon dioxide. Then I multiply it by the grams of carbon, and I got this much grams of carbon in the first experiment. Then I found the percentage of carbon in that experiment, and so since I got this many grams of carbon, I divided it by the grams of the compound in the first experiment, which is that, and then I multiply it by 100, which I got 49.47% of carbon. Then I did the same procedure with the hydrogen. So for the hydrogen, I'm gonna need the grams of water, and then so I did that. Then I converted to moles of water. Then I did the mole ratio from hydrogen to mole water. And then I multiply it by the grams of hydrogen. So I got that much hydrogen in the compound. And then I did the same thing as the carbon. I divided it by the grams of compound. Then I multiply it by 100. So then I got this much percent of hydrogen in the compound. So since I already have the percentage of hydrogen and the percentage of nitrogen and oxygen, I can just subtract from all of that from 100, and that's what I did right here. The percentage of oxygen is 100 minus all the percentages of the other elements. So I got 16.47% of oxygen in the compound. So then from there, I did the stoichiometry, assuming that 100 grams of the compound. So I did it for carbon, hydrogen, nitrogen, and oxygen, and then I divided it by the molar mass of the element, and I got this numbers right here. So then at the end, I just divided them by the lowest number, so which it was 1.03 of oxygen. So I did that for everything, and then I got 4 moles of carbon, 5 moles of oxygen, and 2 moles of nitrogen, and as well as 1 mole of oxygen. So this is the empirical formula for the experiment. But since it's asking me for the molar mass, no, to find the molecular formula of the compound, I used this formula right here to find the empirical units. So from the molar mass, I divided it by the empirical mass. So the empirical mass, I found it from multiplying. So I got 97.10 grams over mole. Then I just plugged in that number here. This number I got it from the given ones. So I got 2.06, which was roughly 2. So I just multiply all of the empirical formula by times 2. So I got C8, H10, N4O2. So that was the molecular formula for the compound.